Welcome back. In this lecture, we are going to do examples on Gaussian elimination method. In the previous lecture, we gave the steps that you need to carry out for you to solve a system of linear equations by Gaussian elimination. So in this video, in this session, we are going now to demonstrate how you apply those steps to specific examples. So this is the first appetizer. To solve the system, 3x plus 4y equals to 18, 4x minus 3y equals to -1 by Gaussian elimination. So solution. The first step was to rearrange the system in augmented form. And you see this one is very easy to see that the augmented form is given by 3, 4, 4, minus 3, and then 18, and then -1. So this is step 1. And then step 2 is to use elementary operations to reduce the system into row echelon form, or to arrange the augmented matrix in row echelon form. So step 1. So remember, because this system involving 2 equations, then the row echelon form structure should be 1, and then 0, 1. So this should be the structure, the staircase. So we have 3, 4, 4, minus 3, and then we have 18, and then -1. So the first step, we expect this one to have 1. So we'll say row 1 to be, so for us to get 1 if this 3, then I need to divide by 3. So I say a third row 1. And then I keep row 2 to be the way it is for the first step. So by doing this operation, we'll have, so when you multiply a third by row 1, it means that every element is multiplied by a third. So therefore we'll have 1, 4/3, and then 18 divided by 3 is 6, and then this remains to be 4. This is -3, and then this -1. So at least now the leading one has already been obtained in the first row. Now, therefore, the remaining part is this one here. We expect this one to be 0. So because we have already corrected row 1, so we say this step row 1 remains to be row 1, and then row 2 will be row 2 plus a constant, and then row 1. So what do we multiply by 4 so that by 1, so that when you multiply by, when you add by 4, we get 0. So we see that this constant must be -4. So that -4 times 1 is -4. Then when we add to 4, we get 0. So that operation now will lead us to this may be 1, 4/3, and then this is 6. And so 4 plus -4 times 1 is 0. And then -3 plus -4 times 4/3. That gives us -25/3. And then the other one is -1 plus -4 times 6, which is -24. That's -25. That's what we get in that step. And we also expect this one to be 1. So for us to get this one 1, so we maintain row 1 to be row 1, and then row 2 will be given by, so what do I multiply by -25/3 to get 1? That should be -3/25 R2. So because negative 3 over 25 times minus 25 over 3, negative, negative, 3, 3, 25, 1, 25, 1. So get 1. So therefore, I'll get 1, 4 over 3, and then 6, 0, 1, and then negative 3 over 25 times minus 25. So this is this negative 1. So that's positive, positive 3. And so this now the row echelon form of the system. And so remember, the first row corresponds to x1, first column corresponds to x1, this one corresponds to y, corresponds to x, this corresponds to y. So from which we have the system x then plus 4 over 3y equals to 6, and then y equals to 3. So now using back substitution, we get y equals to 3, and then from the first equation you'll have 5 x plus 4 over 3, where this y put 3 equals to 6. So x plus 4 equals to 6. So x equals to 6 minus 4, which is 2. So therefore, the solution is x equals to 2 and y equals to 3. So that's how we solve that given problem. And then number 2, second example, x1 minus 2x2 plus 3x3 equals to 9. And then I have minus x1 plus 3x2 equals to minus 4. And then I have 2x1 minus 5x2 plus 5x3 equals to 17. So the first step is to rearrange the system in augmented form. So because the second one doesn't have an x3, we can just force an x3 to be here. So solution, augmented form is given by 1 minus 2, 3 minus 1, 3, 0, 2 minus 5, 5, and then 9 minus 4, 17. So this is the augmented form of the matrix. And remember, this column corresponds to x1, this one corresponds to x2, this one corresponds to x3. So after arranging in the augmented form, is now where we start now to do our row operations. So we have, so next step, row operations. So we have 1 minus 2, 3 minus 1, 3, 0, 2 minus 5, 5, 9 minus 4, 17. Now, because we have 3 equations, then the row echelon form structure should be this. We should have 1, 0, 1, 0, 0, 1. So this should be how our staircase pattern should be. Ones along the main diagonal, and then this should be zeros. Positions can be taken by any number. So at least this one we are okay with. We are lucky that it corresponds to 1. But this is a problem. This is also a problem. So first step, we say that row 1 to remain to be row 1 because we have the correct position of 1 in this case at this point here. But row 2, we need to make this one 1, or we need to make this position 0. So by saying row 2 plus a constant row 1. So what should you multiply by 1 so that when you add to -1, you get 0? So that should be 1 or +1. And then so the rest we just do step by step. So row 3 to remain to be row 3. So this one leads us to 1 minus 2, 3, 9. And so -1 plus 1 is 0. 3 plus 1 times -2 is 1. 0 plus 1 times 3 is 3. And then -4 plus 1 times 9 is 5. Then you say that we keep row 3. So that is the answer for that step. So we see this one is okay, this one is okay, this one is okay, but this 2 should be 0. So we say row 1 to remain to be row 1, row 2 to be row 2, and then row 3 to be row 3 plus. So we still use the first row to correct this third row. So row 1. So what do we need to multiply by 1 so that when we add to 2 we get 0? That must be -2. So that we'll have now, this will give us 1 minus 2, 3, 0, 1, 3, and then we have 0. And then -5 plus -2 times -2. So it's like -5 plus 4, which is -1. And then 5 plus -2 times 3, which is 5 minus 6, which is -1. And then 17 plus -2 times 9, 17 minus 18 is -1. So this okay, this okay, this okay, this okay. The problem is here. So row 1 to be row 1, row 2 to be row 2. But then now for us to get 0 here, then we'll say row 3 to be row 3 plus a scalar. Then so we now use row 2 to correct this position here. So you need to multiply 1 by 1 so that when you add to -1, you get 0. So next step will be 1 minus 2, 3, 9, 0, 1, 3, 5, and then 0. So this will be 0 minus 1 plus 3 is 2, minus 1 plus 5 is 4. So the only problem is this part here. This should be 1. So therefore, to correct that this position, if I have 2, then to get 1, I need to divide by 2. So I say row 1 to be row 1, row 2 to be row 2, and then row 3 will be a half of row 3. So that now my next step will be 1, -2, 3, 0, 1, 3, 9, 5, 0, 0. This will be 1. A half of 4 is 2. So you see now this structure, this is the row echelon form matrix of the original augmented matrix. So therefore, from this one now, you remember that this first column is x1, this x2, this x3. So the equation corresponding to the system corresponding to this given augmented structure is, so from which we have the system x1 minus 2x2 plus 3x3 equals to 9, and then x2 plus 3x3 equals to 5, and x3 equals to 2. Now, by back substitution, we have, so clearly from the third equation, x3 is 2, and then second equation, x2 plus 3, where there's x3, you put 2, will give us 5. So which tells us that x2 plus 6 equals to 5. And this will be true if and only if x2 equals to 5 minus 6, which is -1. And then equation 1, x1 minus 2, where there's x2, you put -1, plus 3, where there's x3, you put 2, should give us 9. So this would be x1 plus 2 plus 6 equals to 9. X1 plus 8 equals to 9. X1 equals to 9 minus 8, which is 1. So therefore, the solution to the system is x1 equals to 1, x2 equals to -1, and x3 equals to 2. So that is the those are the answers to our system. So in this next video, we will also give more examples on Gaussian elimination. So thank you.